All right, so we are starting to talk a little bit more about the last part of dimensional analysis that you're going to have to be responsible for understanding. And that is, in this particular instance, going to be um, dimensional analysis with something that we call derived units. Now, a derived unit is a unit that we get when we um, multiply or divide things. So in this instance here, we know that we are multiplying or dividing base units, and we do that, we get what we call a derived unit. It's a unit that you can't measure with a measuring device. You have to do some math with it. So, for example, um, if I said that we wanted to find the area of a block, right? So here's my block, and if I said this is my length and ah, this is my length and this is my width, I would just simply take length in meters times width in meters and get the unit of area, which is meters squared. There's no actual measuring device that I know of that you can just go ahead and put down on the ground and gives you area. Even the device itself, some do have the ability to do that, has to do some math. So let's talk about two different types of um, uh, derived units that you're going to be responsible for working with. One of them is the volume, which we just talked about. We take length times width times height. And when I say derivation, I'm really talking about the formula or how we get that. Now, the unit for volume is technically the cubic meter, and the unit abbreviation for volume is the meter cubed. However, the meter cubed is really ridiculously large, so sometimes we're going to use the centimeter cubed. Another type of derived unit is density, and density is the ratio of mass to volume. And so in this case, this formula is going to be mass divided by volume, and we're going to spend more time with that in the next lesson. The unit for that is kilogram per cubic meter or gram per milliliter. And so we have these two values here in terms of its unit. Now, the first thing that you're going to be asked to be able to do is to convert from one derived unit to another derived unit. So here's an example of one that you will see in your note sheet. So just like we've done before, we're going to take our so we are going to take our given, which is 7,480, and it's grams per milliliter. And so, and then our unknown here is going to be number of, in this case, kilograms per liter. So it's this part right here. And then I should probably back up for a second and talk for a minute about what grams per milliliter means. In your life, you've probably heard the phrase miles per hour. And specifically, I'm going to give it a value. So we're going to say like 60 miles per hour. But what that really means is that that's the distance, so 60 miles, that an object would travel in 1 hour's time. And so that's what we talk about when we mean a derived unit. So grams per milliliter is really going to be, in this instance here, I'm going to have 7,480 grams, and that's going to be dissolved in 1 milliliter. So that's what this relationship tells me. And so the next thing that I'm going to do is I purposefully set this up first because it's a little bit easier to see what our path or what we're going to have to do is following this. So I'm going to pause this for a second. Be right back. All right, we're back. I wanted to grab the conversion sheet because that's something that is going to be important for us. So in this case here, we're going to go from grams to grams per milliliter to kilograms per liter. So what I'm going to do is I'm going to hop over here to our conversion sheet. And our conversion sheet right here, we have mass. And mass is in grams. So I'm going to look down and see if there's a relationship between grams and kilograms. And there it is. There is a relationship between grams and kilograms. So now I'm going to pop back to the lesson, and I'm going to say that we're going to convert grams. We're going to convert grams to kilograms. So that's the first thing that we have to do. Okay. And so then the next thing that we're going to do is we are going to figure out the relationship for that. And we just saw that there are 1,000 grams equal to 1 kilogram. And so I'm going to set this problem up down below where my unit of grams is going to cancel out. And my unit of grams is going to cancel out when I put the unit on the bottom. And if I'm trying to get kilograms, that needs to go up on top. And then I'm just going to fill in my value. So I have 1 kilogram is equal to 1,000 grams. Now, don't write anything for a second here because I just want to kind of try to prove a point. If I multiply straight across here, hopefully we might see by now that the unit of grams is going to divide or cancel out. And my unit at this point is going to be kilograms per milliliter. And I don't want kilograms per milliliter. I want kilograms per liter. So I need to continue this problem so that my units continue to cancel out. So now I'm going to go one step further, and then I'm going to go and consult the common conversion sheet. And when I consult the common conversion sheet, under volume, I see that milliliters and liters are equal to one another, and 1 liter is equal to 1,000 milliliters. So I'm going to head back over here, and I'm going to write down that relationship. So the relationship is 1,000 milliliters is equal to 1 liter. So now my problem is going to go from grams to kilograms, but it's going to go then to milliliters, and from milliliters it's going to go to liters. So again, this is where students can sometimes get a little bit confused. So if I start with my unit of milliliters on the bottom and I want to cancel it out, I need to have milliliters. I need to put milliliters on the top. At this point, now I have milliliters on top of this fraction and milliliters on the bottom of this series of fractions, which gives me the ability to cancel it out. And I'm going to put liters down here, and then I'm going to fill in the relationship that 1 liter is equal to 1,000 milliliters. Now we're going to scroll up a little bit here, and we're going to do some math. So we're going to multiply straight across the top. And we multiply straight across the top. We get 7,480 times 1 times 1,000, and that really ends up being 7,480,000. And my unit here is going to be grams, kilogram, and milliliter. Oops. That to be that color. And then I'm going to make this a fraction by drawing a line underneath it. And then I'm going to multiply 1 times 1,000 times 1,000, and I'm going to get 1,000. And my unit this time around is going to be milliliters, grams, and liters. And so at this point, hopefully we can see that the unit for milliliters cancels out and the unit for grams cancels out. And so when I divide this out, my final answer is going to weirdly be 7,480 kilograms in 1 liter. All right, so that's the first sample problem. So now we're going to jump down and do the second sample problem. And this one is the same idea. It's a derived unit. So we're going to start just like we did the last one. So I'm going to take 60 miles per hour, per hour, and we are going to convert that to number of feet per second. So just like I did before, I'm going to set the problem up underneath here to start with. So I'm going to take, so I'm going to take 60 miles and put that over 1 hour. And now I'm going to set this up to convert miles to feet. So I'm going to go back to my common conversion factor chart, and I see that there is a relationship between miles and feet. 1 mile is equal to 5,280 feet. So we're going to use that. So I'm going to say that 1 mile is equal to 5,280 feet. So when I set this up, just like we did the last time, I'm going to put miles on the bottom, and I'm going to put feet on the top, and I'm going to fill in my values, 5,280 feet on the top and 1 mile on the bottom. So at this point, we've gone miles to feet, and now we need to go from feet, now we need to go and deal with our hours because our miles cancel out. So we're going to change hours to minutes and minutes to seconds. So that means that we need to have some relationships. So we need to know the relationship that 1 hour is equal to 60 minutes. And we need to know that 1 minute is equal to 60 seconds. So I'm going to go ahead and continue to set up my problem where I need to get rid of hours and eventually get rid of seconds. So again, just like the last time where students sometimes make a mistake is where do you put the unit of hour? And we want to put the unit of hour on the bottom, or on the top rather, and the unit of minutes on the bottom. So we have 60 minutes and 1 hour. And now we want to get rid of minutes. So because minutes is on the bottom, I need to put minutes on the top and seconds on the bottom. And in this case, we have 60 seconds is equal to 1 minute. So with this problem here, I'm going to multiply straight across the top, which is 60 times 5,280 times 1 times 1. And that's going to give me a value of 316,800. And my units, like we've been doing all the time here, are going to be miles, feet, hours, minutes, and then we're going to divide that by 1 times 1 times 60, which is 3,600. And that's going to be miles, minutes. Oh, got to throw in hours in there because I forgot it. And seconds. And again, my units cancel out, miles cancel out, hours cancel out, minutes cancel out. And when I divide this out, we get a value that's going to be equal to 88 feet per second. All right. So that's this part of dimensional analysis. There's one more part that I want to talk about that's a little bit off to the side. So I'm going to make a separate video for that. So we're going to stop this video here, and then we'll pick up that other part in a moment.